Hello everyone, in this video we're going to be looking at application of quadratic functions, and a place where we're going to see an application of quadratics is in projectile motion problems. A projectile motion problem is really just a problem where we throw something in the air or shoot something in the air and the gravity ends up pulling this thing back to the ground. And this is usually going to create a parabola, just like the graphs that we have been creating. And this can be modeled with a quadratic function. So it's often going to be named h of t, which is going to be short for the height as a function of time. And every object in projectile motion has the same force upon it, which is gravity. Therefore, they will have a leading coefficient of -16 if we're talking about feet, or it's going to be -4.9 if we are talking about meters. Okay, so there's an example of a projectile motion equation down there at the bottom where we have h of t is -16t squared plus 192t plus 50. Okay, so let's take a look at some examples of this. So first example, we have a water balloon that's launched straight up, and the balloon's flight is modeled by the function h of t is -162t squared plus 192t, where h of t is the height in feet after t seconds. Answer the following questions graphically. So the first question, at what height did the water balloon start? Okay, and we are going to find that on our y-axis. That's where it starts, okay? So this thing is starting at a height of 0 feet. Okay, our starting point is always the y-axis in these problems. Okay, the next one, when did it reach the maximum? Our maximum is always going to be the vertex. Okay, so if I am looking for how long, if I'm looking for when it reached the maximum, that's going to be our x value, okay? Okay, so our answer here is going to be 6, and we're talking about 6 seconds in this problem. And let me write this, at what height we started. Whenever we see the word start, that's going to be the y-axis, okay? The next part, what is the maximum height? So if I actually want to know the maximum height, that's going to be the y value of our vertex. Okay, so the y value of our vertex is, in this problem, 576 feet. Next question, when did it hit the ground? Whenever I'm looking for when something hits the ground, I want to know when the height is 0. If my height is 0, then I am on the x-axis. Okay, so right here, this is when we are on the x-axis. So we're going to say after 12 seconds, we are hitting the ground. And then next question, would the domain be all real numbers? Okay, the answer to that is no. The domain is not going to be all real numbers. We actually have a limited domain, okay? So our domain is actually going to start at 0 seconds, okay? And it's going to go until 12 seconds. It stops when this balloon hits the ground. So I'm going to say our domain is any x value that is greater than or equal to 0 or less than or equal to 12. That is going to be our domain on this one. Okay, so here's another one. We have a ball that is thrown off the top of a building. Its height is modeled, or its flight is modeled by the function given there, where h of t is the height in feet after t seconds. Answer the following questions using the graph. So the first one, how tall is the building? Okay, so the ball is being thrown from the top of the building. So when the ball first flies, that's where the top of the building is. So that's going to be our y-intercept. So the building in this problem is 112 feet. Next question, at which time was the height of the ball at 200 feet? Okay, so when was the ball 200 feet? That would be right here, okay? And that is, it looks like we're being scaled by 1, so it's after 1 second. The height of the ball is 200 feet. Next question, when did it reach the maximum height? That is your vertex, okay? So the x value of our vertex is right here. After 3 seconds, we are at our maximum height. Next question, what is the maximum height? That is the y value of your vertex. So we have 256 feet. And then how long was the ball in the air? So we can see over here that the ball hits the ground after 7 seconds. That is our x-intercept right here. So 7 seconds, the ball was in the air. And that's basically it. We're just reading the graph and we're describing what we're being asked to describe there. But sometimes we're not going to have that graph. So if we're just given an equation and we have to find characteristics of something, here are some hints to kind of help us. So if I'm asked the question, at what height did the object start? Okay, that is the y-axis. Everything starts on the y-axis, okay? So what we're gonna do is we are gonna set x equal to 0 and solve this thing. And that's going to tell us what our original height is. When did it reach the maximum height? We want to find the x value of the vertex. Okay, and remember back we did a ton of these problems. The formula for that is x is equal to negative b over 2a. That's how we are going to find that time, okay? What was that maximum height? That's going to be the y value of your vertex. So we're going to take that x value that we already have, and we are going to sub it back in for y. And then when did it hit the ground? That is when y is equal to 0. So we're going to set y equal to 0 and solve. We may be able to solve this thing used by factoring. We might have to do the quadratic formula to solve these things. All right, but those are some hints to help us solve here. So here's another example. It says, in an effort to catch a criminal, a superhero is going to leap over the building and take a shortcut down the alley. The function f of x is equal to negative 16x squared plus 150x gives the superhero's height in feet as a function of time. The building is 425 feet high, okay? So how many feet in the air is he after 2 seconds? All we have to do is substitute that 2 in. So here we're going to say that f of 2 is equal to negative 16 times 2 squared plus 150 times 2. So if I put that in my calculator, I'm going to get 236 feet. Okay, so that's how high he is after 2 seconds. How long does it take for him to reach a maximum height? We need to find the x value of our vertex for this one. Okay, so we're going to use the formula x is equal to negative b over 2a. So the opposite of b is going to be negative 150 over 2 times negative 16, which is just negative 150 over negative 32, which is 4.6875. And then what is that maximum height? So we're just going to have to sub that in to the original equation. So we get negative 16 times 4.6875 squared plus 150 times 4.6875, and that is going to give us about 351.6 feet. So that's the maximum height that he's going to reach. Last question, will he make it over the building? The answer is no, he does not make it high enough to get over the building. So our answer is no to that. Okay, here's one more example. It says Cameron is trying to dunk a basketball. He needs to jump 2 feet in the air to be able to dunk the ball. The height that his feet are above the ground is given by the function negative 16t squared plus 12 times t. Okay, so what is the maximum height your feet will be above the ground? So, or Cameron's feet. So we need to find the vertex again. So we're going to do x is negative b over 2a. So that's going to be negative 12 over 2 times negative 16, which is negative 12 over negative 32. And that's going to simplify to, let me leave that as a fraction, as 3 over 8. Okay, so it takes 3/8 of a second for Cameron to reach his maximum maximum height. All right, so now we're actually going to find that maximum height. So we're going to take that 3/8, sub it into our equation. So h of 3/8, and then we're going to do negative 16 times 3/8 squared plus 12 times 3/8. Okay, so if we sub that in, negative 16 we end up with 2.25 feet. So will Cameron be able to dunk the basketball? Yes, he can do it because he can jump more than 2 feet. Okay, so be able to solve quadratic word problems. Please go check out the assignment that's on Canvas. Let me know if you have any questions for the day. Have a great day. Thanks.